Hi there. Today we are going to finish up the radical expressions from yesterday. We have a few more problems to dig into, and then we'll be done with the radicals. Great. I am not sure why this didn't come across, but I went ahead and just hand wrote your notes here. Today what we're looking at is changing those radicals into having fractional exponents. And that's what that would look like. If you have a radical like this, if I'm square rooting, that is ultimately the same as taking a value to the 1/2 power. If I was cube rooting, this would be the 1/3 power. Fifth rooting, 1/5 power. Now, sometimes we even root it and take it to a power all at the same time. If that's the case, this index, is still going to be that denominator there, the same way that it was. And then the m is what power you're raising it to. So anytime you see this right here, you've got to think, oh, I'm doing the nth root, and I'm taking it to the m power. That's what that will mean. So just to practice that concept, to switch between a radical to a rational exponent, this is a very, very common one here. A square root is just taking something to the 1/2 power. All right, on B, this is a little bit weirder because I am taking it to the 5th power, and it is also worth noting that I'm taking all of this to the 5th power, not just the y value, not the last value. But I also square rooting. So this is going to look like this, 3xy. You've got to keep it in parentheses to show that all of this is going to be raised to the 5/2 power, because the 5 is the power, the 2 is the root. If you don't have the parentheses, I'm going to count that wrong because that would imply only the y value was being taken to that power. Okay, next one. This one's a little messier. Here's what I've got. I've got the 2x, but then I've got more x stuff going on here. So it's actually being multiplied. So it's multiplied by an x to what power do you think? 3/4 power. Now this looks a little bit odd because I have two x's here. I would like to get those merged together. And to do that, I can just think of this as x to the first, x to the 3/4. When I'm multiplying here, then I should just add my exponents. But to be able to add them, they're going to need to have a common denominator. So I'm going to write that 1 as a 4/4. So now I have 2x to the, remember we are adding exponents. So 4/4 plus 3/4 is 7/4. And that's what it would look like with a rational exponent. Now, in class, we did a little activity called Pass the Pen, but at this point, I'm just going to make this video and I'm just going to do all the examples, and I'm probably not even going to have you do any on your own. I'm just going to work through them with you. On this first example, you have an x squared, and it's being raised to the 2/5 power. It's a little bit hard to write fractional exponents. You kind of have to think of it like this is your numerator, this is your denominator, even though they look side by side. So this is going to be a 2/1. So I'm going to rewrite it so you can see better what's going on. It's a 2/1, and then it's going to be a 2/5. Power raised to a power, we multiply exponents. This is a good review here as our test is approaching, and that's those exponent rules from way back. This would simplify then to x to the 4/5. Now, I haven't really even talked about what are the directions here. Well, just kind of cleaning it up. I will on your test indicate, do I want a rational exponent or am I going to want it to be a radical? If I wanted a rational exponent, I would leave it like this. Or if I wanted it to be a radical, the 5 is the root and the 4 is the power. Remember that it doesn't really matter where that 4 goes. You can put it on the outside or you can put it on the inside. Either one is fine. Next one, a to the 0.75. I did not talk anything at all about decimal exponents. But I know that you know that a 0.75 is really a 3/4. A to the 3/4, if I wanted it to be written as a radical, then that would be a fourth root of a to the third. Next one, this is like that previous slide. You have a 3x cubed times, oh goodness, this is silly. I've got the square root of an x squared. What's going to happen with the square root of the x squared? You're just going to get an x. I don't even think I'm going to deal with a rational exponent. This is going to be 3x to the fourth. I probably should fix that problem. That's kind of weird. Next one. I can't really, these bases are not the same. This is a b to the 1/3 and a c to the 2/3. I'm not going to try to combine those with the rational exponents like I kind of did up here. I don't want to do that kind of thing because I have different variables. Really, all I have is the b being raised to the 1/3 power. So that means the b is being cube rooted. The c is also being cube rooted, but then it's going to get squared. The -3 is not getting any of that done. It's just multiplied. So here's what that should look like. If I were to write it out, it would look like this. But there's no reason to have two cube roots there. We would go ahead and merge those. Remember from the other day, you multiply as long as their indexes are the same, indices or whatever you want to say for that plural, that little cube number, as long as those are the same, then you can merge this into one radical. All right, I said I wasn't going to turn you loose, so I'm going to keep working through these. This one is a -32, and then I'm going to be taking it to this root. I'm a little bit nervous. There's a lot of stuff going on right here. A lot of negatives and then this fraction. Here's what I want you to notice. You're ultimately fifth rooting. And it is okay to be fifth rooting a negative. I'm going to go ahead and take this -32 and fifth root it. Fifth root of a -32 is a -2. Then I'm going to take that to the -4 power. Recall from when we did exponents, this negative right here does not make my answer negative. A negative on your exponent means you have to shift this to the denominator. Not only is it going to go to the denominator, it's also going to have to be taken to the fourth power. And if I have a -2 to the fourth power, so -2 times -2 times -2 times -2, I'm going to get a 16. But that 16 has to go to the denominator. I'm actually going to go downward on this. I'm going to do C next. It looks easier. B looks a mess over there. So C, I'm going to change this. To simplify this up, I'm going to switch it to rational exponents. It's being ninth rooted. It's being raised to the third. So it's going to look like this. But 3/9 will reduce. That's really just a fraction of 1/3. Or now that it's reduced, I could go back and it's really that's equivalent to the cube root of A. All right, let's try this next one. Remember our little trick of multiplying these? I could do that, I suppose. I could call that the sixth root of 125, but I'm not sure I love that because I don't know my sixth root, and I don't think 125 is a sixth root. So as great as that idea was, I'm not doing that. I'm going to use my rational exponents. What's really happening here is this 125 is being taken to the 1/2 power. That's what that square root is. But then that is also being taken to the 1/3 power because it's being cube rooted. I see here again that 125 is going to end up to the 1/6 power because I'm going to multiply those. I don't love this because the 125 will not square root perfectly for me, but you know what it would do? It would cube root perfectly for me. The order of writing these doesn't really matter because if I were to write it the other way around, I still would end up with a 125 to the 1/6 power. I'm going to swap them. What is the cube root of 125? Well, that's just a 5 to the 1/2, which then is going to be the square root of 5. That's what that all reduces down to. That one was a little tricky. All right, I'm working my way up to this B. This is my favorite. It looks scary, but I kind of like it. I think it's kind of fun. Here's what we need to do. We're just multiplying. When you multiply common bases like that, you're going to add the exponents together. Those are not very nice fractions to try to add together. Ultimately, I'm going to take my -5 times my 3, and I'm going to have an x to the 5/3, but then I'm also going to have an x to the -3/4. And I need to get those two fractions added together, which means a common denominator. I've got a 3 and a 4, so the common denominator will have to be a 12. That's going to end up being 20/12. And this one, when you turn it into 12ths, is going to be a -9/12. Now, because I have the common denominator, I can actually add those together, and I'm left with an x to the 11/12. I could leave it like that, or if they want it as a radical, here's what that would look like. A -15, and then the 12th root of x to the 11th. That isn't going to simplify any better than that, so, well, I guess this is the answer, or if you wanted to leave it as the rational exponent. Pay attention to directions so you get that right. All right, so that's all we have. That's all the new stuff, the little fancier radical work, trying to tie in those rational exponents. All right, go finish your homework. Good luck.